Alright, this is part 2 of the Trigonometry 2 final exam review. We're going over it, so we're going to start with this right here. From here, I have to go through and actually try and find which identity we have here. So now, everyone, please, do me a favor. Take a look at your, flip to the front, find your reference sheet, please. On the reference sheet, you're going to find that identity. Which identity matches that? So I got one right here. I got one reference sheet. So on my reference sheet, let's see, it says sine, cosine, and minus.
It's sine S plus C.
Right here, sine, cosine, minus sine. It's going to be sine of S minus T. Okay, so it's sine of S minus T. So sine of S minus T is going to be sine of 40 minus 160. So from right here, that's going to give me sine of negative 120. And to find the coterminal, what would I do? Add 360, right? Add 360 because I want to find this on my unit circle. So sine of 240 because I added 360 to that and got 240. And so now I just find my unit circle, sine at 240. 240, sine is the y value. That's negative rad 3 over 2. Answer's A. Alright, so the next one I'm working on is 23. Now, on 23, there's a couple different ways of doing it, so I'm just going to go with what I have. I'm just going to start off with, now, I'm starting, all these are supposed to be sines. So, from right here, I'm going to work this out. So, I'm going to start off with, in this ratio, I'm going to be only dealing with right angles. So, I could look at it from here, or look at it from here. Now, I can't look at it from B because it's halfway for B here. So, I can't say B. So, I can't use that as one of my reference angles. So, from A, this side is opposite, and this one is hypotenuse. So, if I remember, let me see, I'll write it up here. So, it's going to be the sum. Old hippie caught another hippie tripping on acid, right? Okay, so what do we say that was? So we had opposite and we have hypotenuse. So opposite hypotenuse is going to be, okay, sine, right? So opposite hypotenuse is sine, right there. So it's going to be sine of, what was my angle? A, big A, is equal to H, little h, over C. Okay, so now, from right here, multiply both sides by C. So, cancel those out, and I'm left with C sine of A is equal to H. I look to C. That one is one of my answers. Now, if that was not one of my answers, I got to look at it again from the other side, from C. So, from C, opposite is H, and hypotenuse is A. So, it'd be sine of C. Big C is equal to H over A. Multiply both sides by A. So it's going to be, H is going to equal A sine of C. It's not one of my choices. So it's possible to have correct answers, but not be on here. So you're just looking for the one that matches it. So which one expression can be used to find it? So it's going to be B there. All right, so let's go on to the next one for 21. Let's see. Am I in the right spot? Here it is. All right, so what do I have to do to actually fix this one? To be able to do the identity, what do I got to do first?
Y's and X's.
Y's and X's, right? So that's going to be y squared over x plus x squared over x. Now, do they have a common denominator?
Yes.
Yes, they do. So I would rewrite it as y squared plus x squared over x. Now, what do I have there that I need to identify? I just gave you a hint.
The identity.
Identity. What identity?
The cosine.
No, go ahead, say it. You.
Me?
Yes, you.
Isn't it just the
Yeah, so what do you get there? 1. Now, there's the identity right there. X squared plus y squared, or y squared plus x squared always gives me 1. So that's the Pythagorean identity. So I get 1 over x, because all that on top turns into 1. 1 over x is what? So it's going to be secant. So my answer has to be C. Right? All right.
Wait, is it tomorrow? The testing? Thursday?
Okay, so now 24. Let's take a look at 24. So I'm going to go through on 24 right here. So for 24, now, how would I solve for this? What law am I going to use to solve for that? Is it sine or cosine? Huh? Okay, so give me a reason why you would say cosine. Okay. Do we have side angle side?
No. Oh, sorry.
We don't have side angle side, so can it be cosine? So what is this going to be? Law of sine. So it's law of sine. Now, there's another way to show that it's law of sine. Do I have a big A and little a? I have big A and little a, don't I? So since I have big and little, that's going to be a law of sine, always. If I have a big and little, it's going to be a law of sine. So since it's law of sine, I'm going to set it up. Now, to be able to do that, I need to know big B. So to find big B, you know, all three have to add up to 180, right? So subtract from 180 and we get that big B is? 37? 37? 37 degrees?
37.
You guys agree?
Yeah.
Okay, so now I could use law of sine here. So I'm going to say 95 over sine of 19 equals B over,
Sine 37.
there we go. Do our cross products, I get 95 sine 37 is equal to B times sine of 19. So divide both sides by sine 19. So B is equal to 95 times sine 37 over sine 19. So when I'm doing this, what do I have to make sure? Make sure everything's in degrees, okay? And if your calculator's not in degrees, you would have to force it by putting a degree symbol there. So please calculate that for me, you guys. Let me see. So, control divide. 95 times sine 37
175.6
degrees over sine 19 degrees. Now, if you notice right here, if you're looking on my calculator here, my calculator is in radian, isn't it?
Yeah.
Okay, but why am I able to still get the right answer? I forced the degrees by putting a degree symbol, right? So you could do that, or just change your settings. So please make sure going back and forth when you're doing this, you have to make sure it's in the right mode. So 175.6, so my answer is D. Make sense? Okay, let's take a look at 22. What is the area? So now, there is an area formula on your reference sheet. So please, everyone, write me out. Take a look at your reference sheet and find the area. I want you to find it on there so you know where it's at.
Area of triangle.
Area of triangle. Which one are we going to use?
We got 1 degree A, B meters.
Okay, so I'm going to use A, right?
Yeah.
I'm going to use A.
Yep.
Okay, because why?
Because you have one big A and the other ones are little.
Because right here you have big A here, right?
Yeah.
And so therefore, in this problem, I have big A. So it's going to be 1/2, okay, my b, so it's 13.6 times 10.1 times sine of 42.5 degrees. Let me see. I'm going to change my settings right now.
Oh my god.
So I just went through and changed my settings first. So 1/2 times 13.6 times 10.1 times sine of 42.5.
46.39 meters.
46.4 meters, right?
Yeah.
So my answer is 46.4 meters squared, because area is always squared, right?
Yeah.
There we go.
Oh my god.
Make sense?
Yeah.
Okay. All right, so let's take a look at 25 then. On 25, one measure of angle C with given side lengths. So now, on your reference sheet, it only looks like this. So we're looking for big C, right? But now, we only have one with big C, that's this one right here. I'm going to show you guys how to derive the formula for the angles. This is what I gave to you guys at the beginning of the year. Or not the beginning of the semester. So we're trying to find for big C. So I'm going to use the formula which says I have C squared is equal to A squared plus B squared minus 2AB cosine of big C. That's the formula, okay? Now, I'm going to solve for big C. This is what I did for you guys earlier in the year, and I'm going to show you how to get it, okay? So, I'm going to subtract A squared, and I'm going to subtract B squared. So now it's going to be C squared minus A squared minus B squared equals negative 2AB cosine of big C. How do I undo this multiplication? Divide negative 2AB. Okay, so now that's going to cancel all that. So it's going to be cosine of big C is equal to C squared minus A squared minus B squared over negative 2AB. Now, how would I undo this to try and get the C by itself?
Inverse.
Got to do the inverse. C is equal to the inverse cosine of all of this. C squared minus A squared minus B squared all over negative 2AB. So I derived the formula, and so you could do the same thing for each one. So every single one, there's a pattern to this. There's a pattern. So if you're solving for big C, little c comes first. Little c minus little a minus little b. And these two right here also go on the bottom. Okay? So if we're going to do another one for a here in a little bit, and I'll let you guys do that one using this. Okay, so now for my formula, it's going to be big C is equal to inverse cosine of big C, so 8.2 squared minus, that's a point right there, 9.3 squared minus 5.7 squared all over negative 2 times 9.3 times 5.7. Okay, now we plug that in the handy dandy calculator. So, inverse cosine. Now inside there, control divide, 8.2 squared minus 9.3 squared minus 5.7 squared all over negative 2 times 9.3 times 5.7 And just go ahead and hit enter, and we come up with about 60.8 degrees, right? Now, this one's a serious one that I have to make sure it's in my calculator. So anyone have any questions on that one? Anyone have troubles? Yeah. Okay, so we should come up with 60.8 on that one right there.
Yeah.
Okay, so let's go ahead, take a look at the next one, which is 26. Now, for 26, I need scratch paper. So on 26, now, whenever you see these triangles right here where it says solve for the triangle, and it just gives you a bunch of data, first thing you need to do, draw the triangle. So I'm going to number this 26. So it doesn't matter if the triangle is actually, you know, angles and all that actually match and it looks right. You just need to line up everything correctly. ABC. Big A is 108 degrees, 40 minutes. Big B, or I'm sorry, little b, which is down over here, it's 70.3. Little c is 60.5. Now, given this much information right here, what law do I have to use?
Cosine.
This one is a cosine. It is cosine because it is side, angle, side. Okay, it is, no, side, angle, side. And for this one right here, if you notice, I don't have corresponding sides for any of them, do I? No, so I cannot use law of sine anyway. So it has to be, so there's only one thing I could solve for here, and that is little a. Using law of cosine, I'm going to use that right there. So I'm going to kind of, okay, I mess up the law, and I'll show you why. Law of cosine, you're solving for a squared here. We don't want to solve for a squared, we want to solve for a itself. So how would I undo a square? Square root both sides, right? So that's what I'm going to do here. So I'm going to square root both sides. So I'm going to have, in my formula, it's going to be a is equal to the square root of, that's going to be b squared plus c squared minus 2bc and cosine of a. So that's why I kind of changed up the formula, just because we're trying to solve for little a. Now I'm going to go through and actually plug in all my values that I have for this. So in my values, little a is equal to the square root. B is going to be 70.3 squared plus 60.5 squared minus 2 times B, so it's 70.3, 60.5, and cosine of my A, which is 108 degrees, 40 minutes. So we got to put in the calculator as is. So start off with the square root of, making sure, can you guys see that one? Yeah. So square root of 70.3 squared plus 60.5 squared minus 2 times 70.3 times 60.5. Somehow I got a parentheses in here. Don't do that. Oh, that's why. Right here.
106.4.
There we go. And then I had cosine of 108 degrees. Oh, come on. Why are you not working with me? And 40 minutes. There we go. Close that one off. Hit enter, and I come with 106.4. So my little a value
It's C.
and what are my units on this one? Was this meters? Yeah, meters. All right, so the only one that has little a as 106.4 is going to be C. C is the only one. All right, so let's take a look at 29 now. Now with 29, I'm going to have the same thing. Okay, so I don't know what the triangle is, so I need to draw it. So draw it to see what I have. So that's important to start there. So drawing this, I'm going to have ABC. B is 48 degrees, 50 minutes. Little a is 3850. Little b is 4730. Now, solve for what we have right here. So now, what law are we going to use here? Cosine?
No. Sine.
Why sine?
It's sine because it's angle.
Oh,
It's not angle side.
Okay, look, I have big B and little b, so that's going to be a law of sine right there, right? So, but also, I need to pay close attention because this one is angle side side, isn't it? So, do you guys remember, angle side side means? What's the word, angle side side?
Ambiguous.
Ambiguous, thank you, ambiguous. So there's a possibility of having two triangles on this. So I'm going to go through and do the math, and then we'll check it at the end. So I'm going to use law of sine, so it's going to be
4730 over sine 48 degrees 50 minutes equals 3850 over sine 8.
all right, Jimmy. Let me actually say it because I don't know if people could actually hear you from like way over there.
Thank you.
Okay.
Thank you, Mr. Potter.
Turn off the volume.
I don't have a volume on my mic. I could turn down the Jimmy.
Thank you, God.
No, you can't
I know.
turn down the Jimmy.
Then sine of A. So, because I'm going to use her right here, because that's what I'm going to try and solve for first, because that's the only information I have. I have to solve for A first. Okay, I use this, and I can solve anything else as long as I have corresponding sides and angles. So, from here, I'm going to do my cross products. So, it's going to be 4730 sine of A is equal to 3850 sine of 48 degrees 50 minutes. Okay, so now I'm going to try and divide both sides by 4730. So sine of A is equal to 3850 sine of 48 degrees 50 minutes over 4730. And right here I'm going to take the inverse. So A is equal to inverse sine of 3850 sine of 48 degrees 50 minutes 4730, like this. Put that in your calculator. Make sure your calculator is in degrees. This is not one you could force.
Why is it inverse again?
Are we trying to find the angle?
Yes.
We're trying to find sine A, right? If we're trying to find A, big A, we need to always do the inverse, right? There we go. So it's going to be inverse sine. And 3850 sine 48 degrees 50 minutes over 4730. So we're going to get A is about 37.8 degrees. Now, since this is ambiguous, what do I have to do to find the other angle?
Add the B. I think it's add 180.
Not add 180.
Subtract from zero.
Subtract from 180. So it's going to be 180 minus this. So 180 minus this value. So there's an or here because it is ambiguous. 142.2 degrees. Now, I want you guys to pay close attention because my answers could either stem from this one or it could stem from this one here, because it's a possibility that you could have an answer for A here and another C according to that A. Just like this one, you would have a C according to this A, right? So you have to pay close attention to the ambiguous case. So that's what we have here. So 37.8. So where are we at here? So looks like they didn't use the ambiguous for this. So therefore my answer has to be big A. Not big A, but A. Yeah.
Big day.
I know. Sorry. Caffeine's running out. Say no more. Anyway. So let's take a look at 27. So 27, here's another one. This one is going to be law of cosine. Now this one's going to be a law of cosine, but I want you guys to help me out here. We're going to try and find big A. There's no other angles here. There are no other angles here. So let's use the other formula that we had on, what was that question? One of the previous questions. I can't remember the question. Okay, so it's going to be big A is equal to the inverse cosine of, what's the pattern for this one right here? To find the angle. You guys look at the previous one.
A squared.
A squared
Minus B squared.
minus C squared.
Over 2.
Negative 2. Thank you, Luz. Negative 2. B times C. There we go. There's a pattern for this all the time. So the reason why I know the pattern is because we're looking for big A, so therefore little a has to start this pattern. Okay? So for this one right here, I'm going to have... Alright, so now for right here, let's go ahead and plug this in the calculator. So it's going to be big A is equal to inverse cosine of A. So it's 32 squared minus 49 squared minus 63 squared all over negative 2. My B is 49 and my C is 63. Okay, plug that in the calculator. So inverse cosine. So 32 squared minus 49 squared minus 63 squared all over negative 2 times 49 times 63. Close that off. And we come up with about 30.0 for my angle. So the answer has to be B. All right, questions there? Okay. All right, so let's take a look at number 30 now. 30 is using this one right here, but I'm going to go through and redraw it because it's kind of hard to see. So it looks something like this. C, D, A, 112 degrees, 10 minutes. This one right here is 15 degrees, 20 minutes. And this is 354. All right, so now given this information right here, so the first thing, what's the first thing I'm going to find?
The last angle.
The last angle, angle A. So do me a favor, please go through and find it, and don't forget degrees, minutes, seconds. So 180 minus those. So 180 degrees. And I want my answer in degrees, minutes, seconds, so I'm going to go book, triangle, DMS. So I get 5230. So angle A is going to be 52 degrees, 30 minutes. Okay, so it said find AC, so we're going to be, what letter would that one be? Little b, right? Little b. So now I could use which law here?
No.
Sine. Why sine?
F angle setting.
Okay, which ones do you have to tell you that it's going to be law of sine?
Little a and big A.
There we go. I have little and big A, right? Little and big A. So that's going to be 354 over sine of 52 degrees, 30 minutes is equal to little b over sine, that's a sine, of 112 degrees, 10 minutes. Okay, do the algebra off of this. So do the algebra, cross products. I'm going to come up with 354 sine 112 degrees, 10 minutes is equal to b times sine 52 degrees, 30 minutes. Divide both sides by sine 52 degrees, 30 minutes. So I get b by itself by plugging that in the calculator. Let's see, we get, so 354. I'm going to do all this on top right here. 354 sine 112 degrees, 10 minutes over sine 52 degrees, 30 minutes. There we go. And we come up with 413.2 as my answer for B. So that's going to be B. Okay, questions there? Okay, let's keep going. Number 28. Okay, two ships leave the harbor, enters at same time. So here's the harbor. First ship travels at a constant 16 miles per hour, while the second travels at a constant 20 miles per hour. If the angle between their courses is 120 degrees, how far their